Okay, suppose that $1 in lottery tickets have the following probabilities and values: 1 in 5 to win a free ticket worth $1, 1 in 100 to win $5, or 1 in 100 to win $5, and 1 in 100,000 to win $1,000, and 1 in 10 million to win 1 million. What's the expected value of the lottery ticket? So what you might do here is you don't have to, but you could make a table. Okay, it might help to make a table. And so we're going to list all the possible outcomes. So I could get, well, I got to purchase a ticket. So I'm going to purchase a ticket. Okay, so that's the first thing. And then I can win a free ticket. I can win a free ticket. Okay. And then I could win $5. I could win $1,000 or win $1 million. Not giving y'all enough room to do this. You don't have to do all this. I'm just trying to do this for teaching purposes. So then I made that too. So the ticket purchase, the value, well, let's think about this. If you purchase a ticket, you're losing money. So it's going to be negative $1. So you're going to lose $1. If you win a free ticket, you get $1. It'd be getting $1 back, win $5, $5. So you're going to want these values because you're going to use these values here in a moment. Okay. Next, we're going to do the probabilities of each outcome. Now, this is a little different because, and there's so many ways you could do this, but I'm following the book's example. There's two main ways you can do this. You can include all right, so the probability. Now, the probability that you're going to buy a ticket is 1 because you're 100% buying a ticket. Now, the probability you win a free ticket would be 1 in 5. Probability of winning $5 is 1 in 100. Probability of winning $1,000 is 1 in 100,000. And the probability of winning $1 million is 1 in 10 million. So 1 in 10 million. Now, kind of follow what the book does here on this. It's a little different than the way I normally teach this. Now we're going to do the value times probability. Whenever you do the expected value, you take the value of each outcome times the probability of each outcome. So this would be -1 times 1, which would be -1. So you're expected to lose $1 when you buy a ticket, of course. And then 1 times 1/5 would be 0.2. Okay, so the next one, 5 times 1 over 100. 5 times 1 over 100, that'd be 5 over 100, would be 0.05. So 5 times 1 divided by 100, 0.05. And then 1,000 times 1 divided by 100,000, 0.01. So 1,000 times 1 divided by 100,000, 0.01. And then 1,000,000. All right, times 1 divided by 10 million. Careful here. That's 0.1 on the outcome there. So I should be writing this down. So 1 million times 1 divided by 10 million is 0.1. And so what you're going to do is you're going to add up all the sums of the values times probability. So it's -1 plus 0.2 plus 0.05 plus 0.01 plus 0.1. And so that will give you plus 0.01 plus 0.05 plus 0.2 minus 1. They give you -64 cents. So they ask you to interpret this? Discuss the applications. Yes. Okay. So let's see how we do that. Okay. So basically what this means is you expect to lose. You are expected to lose 64 cents each time you buy a lottery ticket. So now, obviously, 64 cents is not an outcome, but basically, what an expected value does, it kind of weighs out all the possible outcomes. And so for you, what you could say is that, like, for example, if you bought 1,000 tickets, 1,000 times 0.64, you would be expected to lose $640. So it's one of those things to where, yeah, it's a gamble and you can win big, but you're expected to lose. You're gonna the people running the lottery are gonna make their money off of you, or they're gonna make their money off of everybody else playing.